Okay, so it's decreasing from negative infinity to negative 5. Union with, it's also decreasing from 1 to positive infinity, right? Okay, then the intervals on which the function is positive or negative, well, if you'll notice that this part of the graph right here, I'm drawing in blue, is above, and so is this part right here is above the x-axis. So their y values are positive, right? So, by the way, on your assignment today, it's gonna ask you in a different way. It's gonna say where y is greater than 0, which just means the y values are positive. Okay, so it's positive. All right, positive from negative infinity to negative 7, and union with, from where to where? Where else is it positive? Negative 3 to what? 5. Okay, and it's negative from where to where? Negative 7 to negative 3. It's below the x-axis. Also, we put that little union symbol from where to where? 5 to infinity, right? Okay, we already, before some of those guys left, we talked about the end behavior. The end behavior as x approaches infinity. That means as x goes to the right, my y value is going down, right? So as x goes to the right forever, to infinity, y is going down forever. What about as x goes the other way, to the left, to negative infinity? What's happening? What's y doing? As x is going this way, what's y doing? It's going up. Y is approaching positive infinity. Okay? All right. Any questions on any of this? Okay. Go ahead and turn in your bell work if you haven't done so. Okay. Right here, I have, how many different functions do I have? Not 4. 3. What are my functions called? Okay, I have f of x, g of x, and h of x. What does this column represent? What x is, right? So what it's saying right here, well, if x is negative 3, then in the function f, when x is negative 3, y is 5. In function g, when x is negative 3, g is 2. And in function h, when x is negative 3, y is negative 3. Okay? What I want you to tell me is which of these 3 functions is there an x-intercept at 2 and negative 2? Which of these have an x-intercept at 2 and negative 2? See if you can find those. Which of these have an x-intercept at 2 and negative 2? Discuss that in your groups. And when I stand back here, I can see how crooked my lines are. So yeah, the correct answer is G. Why is it G? Okay, so when x is negative 2 and 2, the y values are 0. That indicates an x-intercept, right? Because when you graph something, your x-intercepts, that could be negative 5, 0. That right there, 1, 0 maybe, and this one 4, 0. The y coordinates are 0, right? At an x-intercept. So
like 3 different equations.
right. Well, if you put x into f of x, you get this, these, right? Okay. If you put x into the g function, you get these numbers, right? They're 3 separate functions. Okay, they represent 3 separate functions. All right, I forgot to talk about the objective. Going back here, you guys. The objective is today you will identify key features of functions given graphs, tables, or verbal descriptions. So like on this one, we identified x and y intercepts, maximums and minimums, where it's increasing and decreasing, where it's positive and negative, and we identified end behavior. We've done this. We did a little bit of it last year. We did some at the first of this year. They keep bringing it up throughout the year in this new math curriculum so that students are reminded of these things. And you guys remembered a lot of it, didn't you? Kind of. You remembered a lot of it. Okay. The next thing we want to talk about is these 2 types of functions. Rational functions and radical functions. Now, we have talked about both of these types of functions in the past. We talked about rational functions at the very first part of this year, and we talked about radical functions last year. Do you remember, what does it take? What is special about a rational function? What feature of the equation makes it a rational function? What's special about the rational function that... Okay, a radical one has one of these, Audrey says. It does, but there's something else about it too. Well, what do you mean by that? Okay. Not an exponent, but something else. What has to be inside the radical for it? It has to have a variable. That's right. So something like this would give us a radical function. There must be an x inside the radical. I would write that down. Okay? There must be an x inside the radical, a variable in the radical for it to be a radical function. Most of the radical functions that you see are usually square root functions, which the graph of that's going to be half of a parabola, but it's going to be turned sideways. Okay? It could be that half, or it could be a bottom half of one. And it could also be going in the other direction. It's going to be one of these right here. It's going to be one of those shapes right there. But that's what a square root function looks like. Now, if you've all of a sudden you've put different indexes in here, like a cube root or a 4th root or a 5th root, it's going to change. All even roots are going to pretty much look like a square root function like these. And all odd roots are going to go something like this. Turn sideways, or like this. Okay? So that's what's going to happen with those kinds of functions. So these would be odd indexes. And these would be even indexes. So a radical function, special feature is that it has to have an x or a variable inside the radical. What is a rational function? What's its special feature? I should know this. We learned it the first year. Say that again? They have a fraction. Well, just like this one had a radical, this one has a fraction. But what about that fraction? The variable is in the denominator. So we might have something like this. Okay, everybody write that down. The variable, for it to be a rational function, there must be a variable in the denominator. And that's what makes it a rational function. And rational functions, you know, there's one thing that most every rational function has. Do you guys remember what just about every rational function has? One of those thingies that you can't remember the name of? Yes, that's it. They have asymptotes. What is an asymptote? Yeah, it's imaginary barrier or imaginary line that the graph gets closer to, never touches. We have vertical asymptotes like right here, or horizontal asymptotes like right here. This one has a vertical and a horizontal. Okay, they don't always have to be along the axes, by the way. This one like has a horizontal down here and a vertical along the y-axis, but you can shift functions around so that the asymptotes change around. But they have those imaginary barriers, and usually the vertical asymptotes are created because, like on this one right here, what number can you not have in the denominator? Which one makes it domain undefined? What would make the domain undefined in this one? What? Yeah, why negative 5? Negative 5 plus 5 is 0. Can you divide by 0? No, it's undefined. Okay, so there's usually a vertical asymptote wherever, for whatever number you can put in for x in the denominator and make the denominator 0. And I told you that not all rational functions have asymptotes, because if I give you something like this, if I give you a rational function like that, that one has no asymptotes. That one has no vertical, no horizontal, no slant asymptotes. The reason being is because there's no number you can put in for x and make the denominator 0. Put 0 in, 0 squared plus 4 is 4, right? If you put a negative number in, you're going to square it and get a positive number, and add a positive number, you get a positive number. Same with if you put a positive number in there, you're going to get that. So there's no vertical asymptotes, and then slant asymptotes are determined by the degree of the numerator compared to the degree of the denominator, slant and horizontal. And if the degree of the top is more than 1 more than the bottom, there are no horizontal or oblique asymptotes. And so some rational functions have no asymptotes, but very few of them. Most of them do have asymptotes. Okay? So these are rational and radical functions. By the way, you guys are going to be given a rational function on your assignment today. And it's going to look something like this. I'm not going to give you the same exact one that's on there. I want everybody to put it in your calculator, because no one could figure it out in my first class how to put that in your calculator. They all kept getting lines. And this one definitely is going to have at least one vertical asymptote. It's going to curve. Sorry. For those of you who don't automatically put a fraction, you got to put parentheses around the 3x. Otherwise, if you just go like this into your calculator, it looks like you're putting it in right. But what happens is it reads it like this, 4/3 x plus 2, which is a linear equation. Does that make sense? So don't put it in like this. You got to put parentheses around the 3x. Some of you guys got it. Good job. All right, so there's one on there that you need to do it like that. Okay? By the way, this has a horizontal and a vertical asymptote. I'm going to let you guys figure out where they are. Okay, and the one on the assignment today is similar to this. Okay, one other thing I want to teach you. What if I told you that you have a function? I want you to write a function that has 5, 0 and -2, 0 as your x-intercepts. Do you guys remember how to write an equation that has those as its x-intercepts? And not only that, that has a y-intercept at 0, -5. Would you be able to do that? Okay, I'm going to give you a second to see if you guys can figure it out in your groups. do you remember that if you are given two x-intercepts, x equals 5 and x equals -2, you can rewrite those in factored form by minusing 5 from both sides of this one to get x minus 5 equals 0, and x plus 2 equals 0 on this one if I added 2 to both sides. If I multiplied those together, those factors, I would have an equation that would have those as x-intercepts. So if I multiplied those together, x squared would be minus 3x minus 10 would be the equation that has 5, 0 and -2, 0 as x-intercepts. Do you remember doing that?
Yeah.
Okay. So that's how you go about creating an equation with x-intercepts. If you're given x-intercepts, you find them. Now, problem is, what's the y-intercept of this problem right here, you guys? Say that again, Eli. -10. Because if you put 0 in for x right here, you would get -10. 0, -10. But I want a y-intercept of 0, -5. Say that again. Actually, well, close. You're on the right track. What'd you say? What'd you say? Huh?
The outside of the.
You put this. You just replaced it with 5. Well, you can't do that because it's got to be the whole equation. It's going to change that. But what if we multiplied? Look, what if I multiplied this the right side of this equation? Thanks, Emily. Yeah, you're good. Thanks. What if I multiplied the whole equation, the whole right side of the equation by 1/2? I am changing the equation when I do this, but I'm changing it to be what the requirements are, which is have a y-intercept of that. Look what happens if I distribute that. By the way, written like this, can you see that the x-intercepts, this still factors to be x minus 5 and x plus 2, doesn't it? So does it still have x-intercepts the same? What it's going to do is change how high and low it goes. But it's going to still have the same x-intercepts. If I distribute that through, 1/2 x squared minus 3/2 x, and 1/2 of -10 is -5. That now will give me the equation with a y-intercept of -5, but it retains having x-intercepts at -5, or 5 and -2. So that right there is the equation that will give me that. Does that make sense? There's a problem like that on your assignments. Problem number 4, if you want to write that down in your notes. Okay? Any questions you want to ask about that one? Okay, I'm going to give you your assignment right now, and you guys have the rest of the time to work on it until about 10 minutes left in class, and then I need to show you something on the internet. Okay? Okay, let me say something about a couple of these problems on here. First of all, number 3. Everybody go to number 3. This is just asking one of the questions I asked you in the bell work problem today, but just in a different way. It says, give an equation of a function for which y is greater than 0 for all values of x. What does it mean, y is greater than 0? Say that again, Ryan. Yeah, you want to write an equation. It's asking you so your whole equation is positive. Remember how we did the intervals on which the equation, that last function was positive and negative? Well, we want every number to be positive. Would every y number be positive? Yeah. Okay. How about this one? None of them would be, right? How about this one? Some would. How about this one? No. How about this one? Yeah. So, a constant equation. I want you know what? I'm going to change the instructions list. I want you to come up with 3 or 4 equations. I want one to be absolute value. Okay? So I want one absolute value function. I want a linear. I want a quadratic. There's only one way you can make linear equations all positive. I drew a picture of it up here. So that's one problem, okay? All right, go to problem number 4. Number 4 is like the one I just showed you. So that one's it. Okay, everybody cross out number 5. At first, when I looked at this, I thought it was a good problem, but until I realized that the t was squared, and we never talked about anything like that. So on number 5, everybody cross out number 5 because we've never talked about when the variable is squared inside of a trig function. So don't worry about that one. Okay. Everybody go to number 9. Number 9. It says plot the function in the grid provided above. Well, it's talking about number 8. So you're, on number 9, you're going to graph number 8. Everybody write that down. Graph number 8. Okay, and then I got to show you something on number 10. Number 10 says find the axis of symmetry for f of x equals negative 6x squared plus 7x plus 5. Well, I'm going to make up another one. G of x equals 3x squared plus, let's go 5x, no, let's go 18x minus 2. And I want to find the axis of symmetry. First of all, what kind of equation is that, you guys? It's quadratic. What's the graph going to look like? What's the graph of it look like? Parabola. Okay, it's a parabola. What's an axis of symmetry? Okay, it's the line that goes right through the vertex that makes the parabola symmetrical, right? If you folded it along that line, that's called the axis of symmetry. Well, let's say this is 1, 2, 3, 4, 5, 6. So if that was 6, then your axis of symmetry would be x equals 6. Now, I almost got this one right. Okay, but this graph does not go to that equation, by the way. I was just making one up. But there's a little formula that I taught you for finding the x-coordinate of the vertex. Remember, the x-coordinate of this vertex right here is 6, isn't it? We don't care what the y is because we're just looking for the axis of symmetry. But there's a little formula called x equals negative b over 2a. Do you remember that formula? If you have a function in standard form, a quadratic function in standard form, ax squared plus bx plus c, if you take the opposite of b and divide it by 2 times a, you will have the x-coordinate of the vertex. Okay? So if I took this one right here, if I went negative b, that would be negative 18, divided by 2 times 3 is 6, and so that makes negative 3. Therefore, the axis of symmetry of this one would be negative 3. But that's not the same one as this graph right here, but that gives you the idea of how to do it. Okay? So that's what I need you to know about that. So I'm going to give you about 5 minutes to work on this assignment for a second, and then I'm going to show you, what time do you have to go? 2:15? And then I'm going to show you guys on the internet some stuff I want you to do. Okay, can you see that, or do we need to turn off the lights? Okay, so what we're going to do is I have some little problems and videos I want you to do on Khan Academy. And they've changed their website. Here's the website, www.khanacademy.org, K-H-A-N. It's on my website, so you can go there and just click on it. I think it takes you to the same page. I think it's still khanacademy.org on that. But if not, khanacademy.org, okay? It makes you sign in somehow, like you can either sign in with Facebook, with Google, or just any email. So pick one of these 3 ways right here. I like to sign in with Google, so I hit this sign in with Google. Choose my Google account. And I sign in. If I can remember it. Okay, then it takes me and it asks if for permission to access your Google account and everything. I just hit allow. And what it'll do is it'll keep track of which ones you have done. So I go right here to this page. It will take you through a little tutorial the first time you get on it if you want. But this is where I need you to see. Right up here, this drop-down menu, it's called Learn. Everybody see where that's at? You might want to hit Learn. Okay, go down to Math. Go down to Algebra 2. And it brings up this page right here, and it has a lot of different math Algebra 2 subjects. I want you to click on the third one, which is functions and their graphs, right here. So if I click on that one, it takes me to all these little videos or problems that they have on functions and their graphs. I want you to go down to this one that says properties and features of functions. These are, in fact, these two right here, properties and features of functions and comparing and interpreting functions, are the two I want you to do. Now, like if you go to this very first video right here, it's like 2 minutes long. It's actually 1 minute and 10 seconds long. Watch this.
The function f of x is plotted below. Highlight an interval where f of x is less than 0. So f of x, which is really being plotted on the vertical axis right over here, x is the horizontal axis. F of x being less than 0 really means that the graph is below the x-axis. So the graph, the function is negative in this interval right over here and this interval over here. So I could put this anywhere right over here, or I could stick it anywhere right over here. Let me stick it right over here. There we go, got it right. Let's do a couple more. So the function is plotted below, highlight an interval where f of x is greater than 0. So I could do this area right over here where the function is above the x-axis, or I could do this area right over here where the function goes way above the x-axis. Wow, it even goes off the page. So let's stick it right over here. Let's do one more. So highlight an interval where f of x is greater than 0. Once again, I can do this region right over here where the function is above the x-axis, or over here where it's above the x-axis. I'll do it here just for fun. There we go.
Okay, then you would go to the next one, and it has a problem like that, and you would go ahead and do it. This one says a function f of x is plotted below, highlight an interval where f of x is greater than 0. Am I there right here? Am I there right here? Yeah. Am I there right here? Am I there right here? Okay, so I can do any of those. Hit enter. And I got it correct. I don't know how he corrected it to do another one. Did he just hit that? Oh, he did. If you just hit the answer thing, it will give you another one. This one, a function f of x is plotted below, highlight the interval where f of x is less than 0. Am I there right now? So then I would check that one, okay? So that's the second one. Then I would go down to this one. Some of them are small videos. Holy cow. This one right here teaches you about even and odd functions. It's 12 minutes long. But then the rest of it shouldn't. If you already know about even and odd functions, or once you got it, you can quit watching the video. Okay? So, yeah, going back to here. Let me go back a page. What I want you to do, whoops. Okay, I want you to go do all these problems right here and here. If you get to any really long videos, you can skip them. I've looked at most of them, you can see, and I don't. The only one I saw was that one where it was really long, even odd. I'm not even concerned as much about even and odd, although I think it is on your end of level, so you probably should know that. I expect you guys to go in to log in and watch those videos right there, okay? I could have you pull up your account and check it to see if you did. You have to sign in. There may be a quiz on this next time, you guys. So if you watch those videos, you'll be well prepared.
Oh, do we need to do the little seconds after that?
Yes, you do.